So here they got a graph of a parabola, quadratic, and it reads that the graph of y equals 2x squared plus bx plus c is shown. Okay, where b and c are constants. So the first thing I want to point out is when it says something is a constant, all it means is that these are numbers here that they're not telling you. They're actual numbers that they're hiding from you. And in fact, we usually have to figure out what they are. And they'll ask the question, what is the value of BC? Now notice there's no multiple choice answers because this is a grid-in. And so how are we going to approach this? Well, you should remember from quadratics that some important parts of quadratics. And the first thing is that we talk about the vertex. The vertex, of course, is right here in this parabola. And we label the x, y coordinates, we call them h and k. Okay, so for this one right here, what is our h and our k? Well, the h is, we're at -1 for x, and then we are at -8 for y. So that's our vertex at hk. Okay, then there's another important thing. What we look at is often the y-intercept. So there's a y-intercept, and what's the coordinate of the y-intercept? Of course, is 0, comma, -6 in this case. Okay, but going back to these vertex here, the vertex, the h of the vertex, that's on this axis of symmetry which goes through the middle, and the formula using this form of, so when we have the form y equals x squared plus bx plus c, that general standard form for parabolas, the way we find the h, the vertex, the x coordinate of the vertex, is the x coordinate of the vertex will equal the opposite of b over 2 times whatever a is. Okay, so in this one, what is our h? Our h was -1. That was the x coordinate. So in our problem right now, we know that the x is -1 for our x coordinate, and it is the -b over 2 times a. But if you look at our equation, they did give us this right here is a. This 2, that's a. So I'm going to put that in for this a. I'm going to go 2 times 2. Right now I've got -1 is equal to the negative of b over 4. And what that's going to come out to be is we've got a -4 is equal to -b, so we know that b is what? That's 4. So we just found b. Now we need to find c. So one way to do that, usually this right here is the y-intercept, and I'll show you why. But now I want to go back and show you a different way you could solve that, and that is when if you're given this graph right here, we've got the graph of the parabola, you should still be able to figure out the equation of that because you're given enough information. So how am I going to do that? Okay, so first of all, I've got, again, my vertex was down here, and the coordinate of the vertex was -1, comma, -8. Okay, so the standard form in vertex form for parabolas is we've got y is equal to, and we have a constant a. Then we do x minus the x coordinate of the vertex, or h, right, squared, and then we have plus k, which is the, remember down here the vertex is at h, comma, k. So in this situation right now, I know the vertex, right? Here's the vertex. This is h and this is k. So I'm going to fill in below this. I'm going to leave this y for now. I'm going to leave this as an a. Don't know that yet. I write an x minus, and then h was a -1. So I'm really doing minus a -1. That's still squared plus, and the k value is, well, so we really have -8. Clean that up a little bit. So when we have y equals some number a, parentheses, x plus 1 squared, take away 8. So we're almost there. We need to just solve for this a value here. Now the way we can do that is let's pick an xy coordinate somewhere on the graph besides the vertex. The easiest one is to take the y-intercept. Again, the coordinate for the y-intercept was 0, -6. So when x is 0, y has to be -6. So now using this equation, I'm going to say, okay, when y is -6, I still don't know a value, but I'm saying when y is -6, the x is 0. Right, so now simplifying that, I have -6 equals, so 0 plus 1 squared, of course, is 1. 1 times a, so I just have a, and then this is a -8. Adding 8 to both sides, I get a equals 2. So I want to get it in this form. I want to get it in the standard form. Well, what do I know so far? Again, what I've got so far is I know that in the vertex form, this form right here, now I know the a value, which is 2. I'm going to have my parentheses there, and I know I had x plus 1 in parentheses squared, and then it was -8. So now to get it to be in this form, I'm going to sort of FOIL it out, which means I'll go over here. I'm going to have y is equal to, I'm going to leave the 2 there, but when I do x plus 1 squared, I might as well just write it x plus 1, x plus 1. And then I'll eventually subtract the 8. So I'm going to have 2, and this is going to be a big parentheses here. And you know, you've got x squared, you're foiling this, right? You got an x times 1, you got another x times 1, so I have plus 2 x's, and then the 1 times a 1, I have a plus 1. That's all in parentheses, take away 8. Now I'll distribute that 2. So again, I have y is equal to 2x squared. 2 into this term means I have plus 4x, and then the 2 into the last term means I have plus 2. And then I have that -8. So simplifying right now, I get that the y is equal to, I have the 2x squared plus the 4x, 2 and -8, I have a -6, okay? And so I'm getting the same answers here. I got, remember before we got that b, this is the b right here, b is 4, and then this is the c value, right? The c value is there, and we know that c was -6. So I get the same answer. But it's good to know how to do it. The way I just did it here would be sort of the correct way you would have done it in class. So you get the graph, you look at the vertex, and you come up with the equation. And here I did it in vertex form, but then I can convert it to standard form here. But in the SAT, they don't ask you just, hey, sometimes just figure out the equation is. They do this little trick where they go, oh, here's the equation, and we're not telling you what this is and that is. So try not to get intimidated by that, but it's good to always review these quadratics because there's always a bunch of them on the SAT. But so that's 2 ways to go about solving a sort of challenging problem like that.